Welcome to my series, a large model Showman's engine, and this one is part 67. This water gauge is becoming increasingly difficult to read, and I'm going to modify it so I can see the water level clearly. When I originally fitted this water gauge glass with the new protector, it seemed okay. Now it's got dirty and it's in a very dark part of the engine, I really can't see the water level clearly at all. The time has come to hopefully improve it. I bought one of these type of water gauges, but unfortunately it was far too small. I'm going to have to think again. This one is only suitable for 5mm diameter glass. The water gauge on the engine is far bigger than the small one I've just shown you. Looking at this image, I notice that you can see the water level in the gauge, but only by shining a bright torch at it. The protective shroud that I made for the water gauge does its job, but unfortunately it makes it very difficult to clean the glass. And getting into a physical position to remove the shroud is incredibly difficult. I remember it being difficult when I made it, but I thought I would never need to remove it. This is a commercial water gauge protector that I bought off eBay. I just wanted to see how it was put together. This protector is too small, so you can really see how small the water gauge is. Here's a size comparison. The union nut in the foreground is 3/8 by 32 threads per inch. And in this clip it shows how the protector is held to the bottom nut. I'm going to have to make one of these myself, but first I'm taking some measurements. This protector is designed to slide over something that is 15mm wide. I don't normally work in millimeters, but to be honest, sometimes it is much easier. And I do get a bit fed up of viewers asking me why I don't use metric measurements. The reason for that is simple. Most of the parts on a miniature steam locomotive or steam engine are in imperial measurements, or at least the ones I work on are. Quite a lot of metric parts are now creeping in, and as we all know, 15mm is 0.590 and a bit. I really don't like the glass on this gauge, for the simple reason the three pieces of glass are all different sizes and don't fit very well. I've had this water gauge in my box of water gauges for quite some time. It's really big, far too big for this gauge glass protector. And also the parts are quite heavy. This water gauge is designed to be screwed into boiler bushers on a backhead. And it really is a bit too heavy to mount onto the existing fittings on my traction engine. It uses 10mm glass, which is quite big really. The external diameter of the glass is not the main problem. The problem is the entire gauge is far too big for the job. I'm going to have to think again. And as for the water gauge protector that I bought, it's far too small. But at least I can see how it's designed to mount onto the water gauge. On a miniature steam locomotive or traction engine, I don't see the point of the protective glass. I've done an awful lot of running of miniature steam locomotives, mainly in the 1980s, and I've broken quite a few gauge glasses. And the glass shattering and sticking in you and doing you some damage is the least of your worries. The main problem is the volume of steam and boiling water that issues forth from the broken glass. That's from my experience of running engines up to 7¼ inch gauge. It's entirely different though on the full size. A while ago I made a gauge glass protector for my Castle Steam V6 boiler. Here's an excerpt from the video I made at the time. And if you want to watch it full length, it's called How to Make a Gauge Glass Protector for a Castle Steam V6 Boiler. So here's the general idea. The two red O-rings put positive pressure on the square brass parts, which in turn hold the four pieces of stainless steel rod firmly in position. But there's a bit of flexibility because don't forget the copper boiler expands and contracts relative to its temperature. So here's a shovel and there's the water gauge. Now if I did this without this protector being in place, there would be several pieces of glass on the bench. I'm going to make a gauge glass protector that looks like this, but I think I will omit the glass. In my workshop I have a pair of Lancashire water gauges, complete with a pressure gauge on the top. The protectors are very easy to remove. I was doing it slowly just to show you how they come off. They can be removed very easily for cleaning and replaced equally quickly. This glass, by the way, is 1/2 inch thick and it's toughened glass. Removal and refitting of the protective glass is very simple, as you can see here. It would be easier if the bottom mounting plate was level. These are quite nice things, and as I run the camera up you can see the cork on the end of the spike because that is really pointy, and here I've just found a bandsaw blade. I think I'll put that with the other bandsaw blade of the pair that I bought the other day. What am I doing with a piece of plastic drain pipe, you may be wondering? I've mentioned that working with this traction engine is very difficult. It's not a bench model, you're sort of half inside it all the time. And for initially loading the kindling wood and the charcoal into the fire hole, it's bigger than the piece of brass tubing that I normally use, and it's a really good fit in the fire hole. Because it's made of PVC, it's only usable for initially lighting the fire, introducing all the fuel into the firebox. Why am I telling you about this? I'm really in this part of the engine to remove the gauge glass and the glass protector and the 2 nuts to allow me to make a new glass protector on the bench in the workshop and then fit it in place. During the removal of this gauge glass I broke it, which was hardly surprising. On traction engines the water gauges are not quite as firmly mounted as they are when they're bolted into a backhead of a locomotive. Here's what's left of the gauge glass, and as you can see it's the painted type. The logic behind this is that the refraction of the light through the water makes the water level easier to see. The glass is 8 mm in diameter, and I've just ordered some more from Blackgates Engineering, but it's just normal glass tubing. I'm showing the principle of this light refraction with some water in the cap of an aerosol can. You can clearly see the water level now the tube has been cleaned. Of course, it's under a lot of video lighting in this clip. Once again, you can see very clearly that when the gauge glass was fitted to the engine, with the torch shining at it, the water level was difficult to read. Now it's time to sit down and look at the parts on the bench so I can figure out the best way to make a water gauge protector that looks quite similar to this one. But without the glass. Maybe I could use acrylic, or would that melt? I don't know. I'll start to make this in the next episode, but for now, stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists, and by doing that you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.